All right, we're going to look at common denominators, and the question we're going to use an example is, what would I get if I added 1/2 and 1/3? So we're going to focus on the 1/2 fraction for a moment. These pieces are not the same size, so we are not able to combine them yet. So what we're going to want to do is make them the same size by getting a common denominator. The denominator in our fraction tells us how big the pieces are, how many equal-sized pieces it takes to make one whole thing. If I start with a fraction of 1/2 and I make one cut, I am now doubling the amount of pieces that I had. I started with 2 equal-sized pieces to make one whole thing. Now I have 4 equal-sized pieces. So this fraction would now be wrote as 2/4, but the denominator started as 2. It would now be 4. If I changed it up and instead of making one cut, I made 2 cuts, what would be happening is I would be taking every piece that I have and I'm splitting it into 3. So I'm actually tripling the amount of pieces that I have, and the next fraction would be 3/6. So my new denominator would be 6. And I'm not changing the value of these fractions. They're all still worth 1/2. But what you're going to notice is if you do enough of these, you're going to see that your only options for your denominators when you start with 1/2 are the 2 times table. Because if I cut it 3 times, I'm multiplying the number of pieces I had by 4. So I had 2, multiply it by 4, and I now have 8 possible pieces. Next one, if I made 4 cuts, I'd be multiplying by 5, I would get 10 pieces, and so on and so forth. So I could write the fraction as 1/2, I could write it as 2/4, I could write it as 3/6, I could write it as 4/8, so on and so forth. If I go over to the 1/3 fraction and I look at it, what are the denominator options? So if I start with 1/3, how else could I write 1/3? Start off with a denominator 3. If I made one cut, I'm now doubling the amount of pieces that I have. I would have 2/6. The denominator would be 6. If I made 2 cuts, I would be tripling the amount of pieces that we started with. 3 groups of 3 would be 9. If I kept up with this pattern, I did 3 cuts, I would be multiplying the number of pieces that we started with by 4. I would have 12 pieces, so on and so forth. And our options for our denominators, if you're starting with 1/3, if you're starting with the denominator of 3, our only option when we're writing an equivalent fraction is to have a denominator that is a multiple of 3. So if we're aware that that's going to happen, our goal here, if we're going to add these fractions together, we need to get the pieces to be the same size. So what we're looking for is to get 2 equivalent fractions where the denominators are the same. When the denominators are the same, it means the pieces are all the same size that we're talking about. So you can look at the 2 times table on the left and the 3 times table on the right and say, well, these are our options. Which number is actually showing up in both? So if I started with 1/2, I could make it into 6ths by cutting every piece twice. You'd be tripling the amount of pieces that you have. If I started with 1/3, I could make one cut, and I would then have 6 pieces in each size. So actually, our common denominator that is the lowest one, the smallest common denominator, the lowest common denominator is 6. So I can rewrite 1/2 as 3/6. I can rewrite 1/3 as 2/6. And if I show that in our model, what's that going to look like? So over here we'd have 3/6, and over here we would have 2/6. And if I combine them together, so that would just kind of be like taking this piece here and filling it in here, and then taking this piece here and filling it in here, and you would see that we would have 5/6 altogether. These 2 would be gone, they would be moved over. So if we were to do 3/6 and 2/6, if the denominators are the same, it means the pieces are the same size. You have 3 pieces, you put 2 pieces with it, you now have 5 pieces. They are 6ths. Once the denominators are the same size, the question becomes much simpler. A lot of students want to add the denominators as well. That's not the case. What if I was to add 3/4 and 1/5? So once you get the hang of it and you do not want to model it, you can use what we just learned from the previous question to do this one without modeling. If you get a tough question, in the future, and maybe it's like 7 30-seconds plus 5 81st, you may not want to model that one, of course, and you may kind of forget how it works. Go back and do a simpler question like this one, or even the first one, and refresh your memory, because they're all going to behave the same. So what we're looking at is if we're going to rewrite both these fractions so that the denominators are the same, we need to write equivalent fractions. Now, we want to compare what our options are. So we're looking at 3/4. The denominator is 4. If we cut all the pieces once, we will double the amount of pieces we have, and it will end up taking 8 to make one whole thing. And our option, once again, is just going to be the times table of that denominator. Any multiple of 4 is going to be an option for that denominator. So our options for the denominator are the multiples of 4. So 16, 20, 24. We look at 5 in the 1/5 fraction. So we can have 5 as our denominator. That's what it starts as. The other options are the multiples of 5, the numbers that are in the 5 times table. And I'm just going to write a few of them out, and then we can go back and check. Is there a number that shows up in both lists? And if there is, we can use that as a common denominator. We can use that as the denominator in our fraction that we're going to rewrite so that we can make all the pieces the same size. So we're going to want to work with 20ths now, because we can see that if I started with 1/5, I could make some cuts and turn it into some number of 20ths. If I started with 3/4, I could make some cuts and turn it into some number of 20ths as well. I cannot take 3/4 and switch it to an equivalent fraction where the denominator would be 10, so that number is not going to work for us. So what happens here is, in order to go from the 4 to the 20, we are multiplying by 5. So we cut every piece here 4 times, which is actually multiplying the number of pieces we have by 5. So whatever you're doing in the denominator, you're going to do the numerator as well, so that it is equivalent fraction. 3/4 and 15/20 are the exact same value, so they are interchangeable. So we can rewrite that. 1/5, I'm taking 5, going to 20, and multiplying by 4, do the same thing to the numerator. So we have 4/20. So we've rewrote the question. It has the exact same value though, so our answer is going to be equivalent to the answer as if we were able to do it up here. If I have 20ths, all of these are 20ths. I have 15 to start with. I put 4 more with it. I have 19 20ths all together, and there's nothing to simplify there.